My name is Kent Haney, and this is my project presentation for N516. The title of my project is 3D printing of temple blocks. So the project started when I was getting into 3D printing and rapid fabrication. I was reading a lot about it, looking at videos, and I started thinking about using it for a project. I saw that people were creating flutes, saxophone mouthpieces, small recorders with 3D printers, so I thought, why not start making percussion instruments? The goal of this project is to create a working set of temple blocks using the selective laser sintering printing technology with the polyamide plastics. 3D printing is the process of making three-dimensional solid objects from a digital model using additive process. This process can also be called additive manufacturing. It was developed in the mid-1980s by Dr. Carl Deckard and Dr. Joseph Beeman, and there are 9 different types of these additive processes. So the 9 types of printing are the fused deposition model, direct metal laser sintering, electron beam melting, selective heat sintering, selective laser sintering, powder-based printing, laminated object manufacturing, stereolithography, and digital light processing. Selective laser sintering is the manufacturing process that I've chosen for this project. It's a high-powered pulsed laser that is used to fuse small particles of whatever material you've chosen together to form your object. The materials that you can use for this process include metals, plastics, ceramic, and glass. The way this works is that each layer is scanned into the computer from the model that you give it, and then the laser comes and it does the outline of a layer. The bed containing all the powder lowers, another layer of powder is rolled across, and then the laser comes by and fuses all the particles for the next layer. Then it drops, and this process repeats over and over until you're finished. One of the cool things that's being done now is that the new SLS machines they've started rolling out with can create objects out of mixed powders. So instead of using just ceramic, just glass, just metal, or just plastic, you can mix different materials together to make these multiple layer things. So here's a diagram of the selective laser sintering. As you can see, it uses on the right side, it uses the laser to melt these particles together, and then you can see on the left how it lowers the bed, rolls another layer of the powder across, and then starts the process again. So the benefits of choosing the selective laser sintering is that it's cheaper than some of the other processes. The materials that it uses are not resin based, so there's no warping or bending while the object is being printed. Selective laser sintering can create multiple parts inside the bed. So if you're creating an object that's like a snap together thing or has multiple moving parts, you can actually set it up so that they're all done in the bed at the same time. You also can choose from a large amount of materials for this process, so you're not restricted to just plastic or just metal. You can do a lot. You can build out of a lot of things. And finally, the leftover powder from each job can be recycled and used in another job, which is fantastic for saving costs in production. The software that I've chosen to use for this project is called Blender, and it's an open source 3D creation suite that's available for Windows, OS X, and Linux. This software has been used to make movies, some video games, and most importantly, 3D printer files. The reason I chose this software, not only because it's open source, which is fantastic, but it's also can be easily used to create files that can be sent to the company I'm using for printing, Shapeways. This project, I'm going to be building temple blocks. And temple blocks are a percussion instrument originating in China, Japan, and Korea. Originally, they were used in religious ceremonies there, and they're also known as dragon's mouths. Temple blocks are used in small and large ensembles around the world, such as band, orchestra, chamber ensembles, percussion ensembles, and they have a distinct and recognizable sound. So, temple blocks are typically made from either wood or hard plastics, and they are played by striking the top with a rubber mallet or a drumstick. And they're all tuned to different pitches, and they have a slit in the side of the block that helps aid in the resonance, and you can change pitch with the by making the slit larger or smaller. So this project will follow the course. I will model the individual blocks in Blender. I will send that file to Shapeways. I will email it to them, and they will print it out. They will ship that back to me in about 8 to 12 business days. And then I'm going to play the temple blocks, record the sound, analyze wave patterns and all that, and compare this to the temple blocks, like the granite LP blocks that are mass produced for use in all the ensembles today. And then based upon that, I will make adjustments for better or different sound production from the next model. And then I'll make those adjustments, send it to Shapeways, and then keep doing this until I've perfected my design for the temple blocks. Future applications for this include, hopefully I'll be able to use this process to create more than just temple blocks. I would like to create maybe frame drums or snare drums. Mallet instruments would be incredible. And I think another cool thing would be to use this to create personalized instruments for people. Say snare drums that have your design on them, or create your own mallet instruments. I think that the possibilities for this technology are fantastic. So thank you for listening. This is my project.